I think we can agree that the past 2 decades have been an extraordinary renaissance of creativity, collaboration, and new forms of social organization on the web. But this has largely been contained to our digital lives. And what I'd like to argue today is that this is just the beginning. That an even larger revolution is about to arrive as we apply these same models to the real world, into the physical space in which we all live. I'll show you just one slide with my thesis statement, and then I'll explain what I mean. But the history of the present can be described in really the last decade was discovering these new sort of post-institutional ways to organize and to work together to do extraordinary things. But the next decade is going to be applying them to the physical objects, the world around us, the space in which we live. And only then, I think, will we see the true impact of what we've invented with the web. I think of this as an industrial revolution. And this is, in some senses, the third industrial revolution. The first was the invention of steam power. And what steam power did is it replaced muscle power with machine power and allowed us to be less about our physical strength and more about our intellectual ability. But it had a consequence, which was that we ended up centralizing and collecting around the machines. And so this picture here represents what an industrial age factory looked like in turn of the century, 18th century England. And labor was organized around the tools of production, which in this case were the factory. And it created the urban phenomena and the flight from the rural world to the cities that we now know today. So that first revolution centralized us as a society around the machines. The second revolution was the information age. And the information age was not a revolution because we invented computers. It was because we democratized computers. It's because we took the extraordinary ability to process information and put it in the hands of everybody. And this took 2 forms. Rather than centralizing the tools of production, we distributed them. And those took two aspects. One was the tools of prototyping, the ability to make something all by yourself. And what I'm showing there on the left is the first laser printer, the first commercial consumer laser printer, the Apple LaserJet from 1986. And that allowed us to in a sense, have our own printing plant, so we could make newsletters or be creative with typography in the way that only major media companies and publishers could in the past. But that was not enough. What was necessary to truly create a cultural revolution was to also democratize the tools of distribution. And that required the web, and blogs, and then Facebook and Twitter, and websites of all sorts. And the combination of democratizing the tools of prototyping and democratizing the tools of distribution allowed everybody to have access to a global audience and created the extraordinary rich and varied and diverse world of voices and ideas and creativity and collaboration that we see today on the web. And that was the second industrial revolution. I believe that we're on the verge of a third industrial revolution, which follows a similar path, but with physical objects. The analogies here, the analogy to the laser printer is, to use one example, the 3D printer. What a laser printer did, and does in your home every day, is converts pixels on the screen, digital bits, to drops of ink on paper. It instantiates digital information into atoms, into physical objects. But it can only do so in 2 dimensions. What a 3D printer does is it takes objects, shapes, geometries from the screen and prints them out into physical objects. The one I'm showing you there is called a MakerBot. I have one in my little workshop at home. It costs $700. It's right where the laser printer was about 20 years ago. And I believe that just as today we all have printers in our home, someday we may all have these prototyping tools, these 3-dimensional prototyping tools in our home. And if you ask me why, the answer is I'm not sure why. Today, if you had asked me in 1986 why everyone would want a printer in their home, I couldn't have told you. I said, well, some of you will be printing newsletters, but the rest of you, I'm not sure. Only later did we discover the digital camera and the idea of printing photographs in your home. And so that equivalent, that sort of killer app for 3D printing and all of its sort of digital prototyping equivalents has yet to be discovered. But I suspect it will happen because the price is coming down so that you can have these sort of tools in your home. And increasingly, a generation that's growing up, figuring out why they want one and what to do with them. But that's not enough. Just like the laser printer was not enough to upturn the publishing industry and overturn the centralized tools of production in the media world, so is the 3D printer not enough. We need a way to reach many, not just the few. And on the right is a website of one. This is just one of many. It's a site called Alibaba, and it's basically an interface into, in this case, Chinese manufacturing. And today, if you want to get something made in units of thousands or tens of thousands, you can do it with a few clicks. It's quite extraordinary. 10 years ago, if you want to get something made, mass manufactured in a factory, you would need to fly to China. I lived there for much of the 90s. You'd have to be introduced to someone. You'd have to, some drinking would be involved, maybe, maybe some karaoke, and over some duration of time, you may win their trust and then get a letter of credit, some bank transfers, and 6 months later, you might get the projects manufactured. Today, you can point and click, upload a file. 10 days later, the prototypes will be on your doorstep by FedEx, and 2 weeks after that, you can be producing any number you want, from hundreds to hundreds of thousands. Anybody can do this. They take PayPal. They take credit cards. You can get robots in China to work for you. It doesn't matter who you are. That is democratizing the tools of production and distribution. This is my grandfather. His name was Fred Hauser. He was a Swiss immigrant in the United States, in Los Angeles. This is him in the 1950s. He was an inventor. By day, he worked for Hollywood. He's a Swiss engineer, so there's a little bit of watchmaker in him. This is probably isn't a very Swiss engineer. And in those days, Hollywood was a mechanical business with tape loops and sound drives. But at home, he invented things, and that was him at his workshop on the drafting board. And what he invented was the automatic sprinkler system. An automatic sprinkler system is really just a clockwork mechanism that turns sprinklers on and off on a schedule, and in a sense it's kind of a natural extension for a Swiss engineer in the dry climate of Los Angeles. But he invented the automatic sprinkler system, and here's his patent for it. And when I was a child, and here I am at the age of I think 6, I would spend my summers with him, and he would teach me how to draw and do mechanical sketching. And he taught me that you could take an idea and you could turn it into an object, that anybody could make anything. And as I got older, here I am at 12, I would spend my summers with him in his workshop, and he had this magical metal lathe and bandsaw and other tools, and we would start with these lumps of metal, and by the end of the summer we would have beautiful machines. But there was a problem. We only ever made one. He had access. We had democratized the tools of prototyping. Anybody could have a workshop. But to get to market, he had to patent it, he had to license it, and then some other company, a manufacturing company, would turn it into a product and then sell it. And so he lost control. And in the end of the day, he was an inventor, but not an entrepreneur. He was only able to do half of the equation. And so as I got older, I chose not to follow that path, because I wanted to reach markets, and I could see no way to go from his workshop to the store shelf without compromising and losing control of my ideas and going through the patent and licensing route. There's a movie that came out a few years ago called Flash of Genius, which tells a similar story. This is about the invention of the intermittent windshield wiper. And this is a scene from the movie. It's very similar to my grandfather. Here's a man in his workshop, and he's got an idea. And the idea is that windshield wipers could pause. If it's not raining very hard, they could just go shh and wait, and shh and wait. And once again, a very simple sort of clockwork timing mechanism. But he did something my grandfather did not do. rather than accepting his fate and licensing it to a big car company to make, he decided he wanted to go and become an entrepreneur as well. Not just an inventor, but an entrepreneur. And to do that in those days, he would have to make his own factory. So he mortgaged his house, and he rented some space, and he started building a factory. And it's not easy to build a factory. It took years. 1961, 1962, 1963, 1964, he's now mortgaged his house for the second time. The factory is still not finished, but it's close. It's a rainy day. He turns the corner as he leaves the factory, and the new 1964 Mustangs are also turning the corner to be unveiled for the first time in the rain, and their windshield wipers are pausing. And he realizes that his idea has been stolen, and he's ruined, and he goes crazy, and that's why it's a Hollywood movie. But that's the story of 20th century invention, which is that you don't control all the necessary elements. You can control the tools of prototyping, but not production. You can make one, but you can't make many. And as a result, this natural ability, this natural democratization effect that we've seen on the web was blocked. And instead, people patented and licensed, and big companies dominated physical goods. Well, things are changing. This is today's factory. It's called Tech Shop, and it's what we call a hackerspace. This right here is like a gym membership, where for $100 a month you have access to all these extraordinary tools. 3D printers, CNC machines, laser cutters, water cutters, plasma cutters, all sorts of machine tools, all this technology and classes to use them. And today, it's full of entrepreneurs who are making physical goods. The guy in the front is making a communication system for the smart grid. At the end of the process, he puts a little sticker that says ABB on it. ABB is a huge Swedish conglomerate engineering company. And when you buy this product from ABB, you probably think it was made by ABB in a big ABB factory. But it wasn't. It was made by a guy in a hackerspace like this. And there are many of them. This is the rise of hackerspaces around the world. You can see they're in Mexico as well. These micro-factories, these tools of production are now spreading so that anybody has access to them. And in combination with this ability to harness global factories to serve you, this sort of democratization of the global supply chain, you can now make one, you can make 100, you can make 1,000, you can make 1,000,000, and it's simply a matter of ideas, software, and knowing where to look. It's not a revolution if it doesn't involve cars. And so one of the big tests on just how big this movement would be is, will it rise up to the full industrial levels of cars? And the answer is yes. This is the world's first open source car. It is the Rally Fighter by a company called Local Motors. And what it uses is a lot of sort of the basic tools of cars, off-the-shelf engines, dials, suspension, etc., a welded steel frame that can be made quite easily, and then a fiberglass body. What's open source about it is the design. A web community was asked to design a car that was inspired by the P-51 Mustang, the airplane you can see in the back. Now, what's great about this is that the barrier to entry for these sorts of cars in the past has always been intellectual property. All the kit cars that were designed over the many years we've been doing kit cars were derivative designs. They were models of famous cars. And they were constantly being sued for trademark and copyright and other intellectual property infringements. And as a result, the industry never grew because it never had its own IP. What we're now doing is we now build web communities that do their own design. They create, collectively, a new form of car. And what's interesting is to look who's in these communities. In the United States, the #1 car design school is called the Art Center in Pasadena. Every year it graduates 120 car designers. Of them, about 20 get jobs in the car industry. The other 100 go off and do something else. They design toothpaste tubes, shampoo. They're frustrated car designers. By night, they still love cars, but their job is not to do cars. What these communities allow them to do is to follow their passions. By day, they design toothpaste tubes. By night, they do what they always dreamed, which is designing a car. And not just designing a car that can and is being made. Today, you can go to a build center in Phoenix, Arizona, and you can, in over 2 weekends, you can make this car. And what's great about you making this car is that you don't need any skills. That mechanic there in the middle will coach you through it. You get a flight suit, you get a toolkit, but now you're not just a consumer, you're a mix of producer and consumer. The regulatory barriers are much lower. These don't have to be crash tested. The liability concerns are not as high because you're an active participant in the process. You're not just someone buying a finished good. You're participating in the creation of something new. And because of that, you're empowered to not only make it, but make it better and fix it. You're an active consumer, and you're part of a new innovation engine. This is what I do. A few years ago, I was playing with Lego Mindstorm's Robotics with my 9-year-old. And then someone gave us a model airplane, which we promptly crashed. And you know, I was thinking, gosh, you know, we're not doing anything very interesting with the Lego Mindstorm's Robotics, and we clearly can't fly the plane. I felt like a failed parent. And I thought, well, what if the Lego could fly the plane? That would be pretty cool. And so my son and I invented a Lego autopilot, which kind of almost worked. And then he lost interest, and I went right down the rabbit hole. And today I have, and I started a community focused on aerial robotics. And what we do is we put computers in airplanes so that they can fly themselves with GPS waypoints. And we create what are called unmanned aerial vehicles, or drones. Very cheap, open source ones for civilian purposes. So this is what you can do these days. I had an idea, I built a community, other people shared this idea, we collectively built something new. And that was pretty cool, a very kind of hobbyist behavior, the sort of thing you might see in the homebrew computing club in the 1970s. We're making robots, we're making flying robots together, but it's kind of a hobbyist thing. But increasingly we saw the potential to do more than just be a hobby. Maybe we could be a company. So we, once again, had the access to world-class tools. These are free tools that anybody can use. We download free tools. We lay out our circuits in schematics. We lay out our circuit boards like this. We upload them to any services that will turn them into printed circuit boards, and off they go. We now have we're now making physical goods. And this is what we make. We make autopilots. And we're not engineers. We just have access to powerful tools. I told you about my grandfather inventing the automatic sprinkler system. I thought it'd be interesting to ask what my grandfather would do today. And the answer is he'd do the same thing, but this time he'd go straight to market. So we're now inventing an open source sprinkler system. Looks like that, inside it looks like that, that's the prototype, but we'll bring it to market. We have no business being in the sprinkler industry. I don't even have a garden. But the fact is, I can do it, and there's other people out there who want to do it together. And there's any number of products that'll work this way. These are the tools you use. You can upload designs to Shapeways and get them printed. If you don't want the device yourself, you can upload them to other sites like Pinocchio. All this stuff can be done for you with a few clicks. So in a sense, the message is finally this, that for the first time in history, making is manufacturing. That workshop can become a micro factory, and you can make one or you can make many. You can print locally or you can print globally. And that is how inventors become entrepreneurs. I wanted to end with a kind of a note about the history of company formation and company organization. The guy on the left is Ronald Coase. He was, in the 1930s, he was asking, why do companies exist? And he came up with the notion of transaction costs. Companies exist to minimize the cost of finding people to do what you need done. So everyone has a job and they work under the same roof. The guy on the right is Bill Joy, one of the co-founders of Sun Microsystems. And he observed in the 1990s a truth, but a very disturbing truth. And that is, what he said is, whoever you are, the smartest people in the world don't work for you. Ronald Coase says, companies have to put people under the same roof and you have to work for the same company to get things done. Bill Joy says, the smartest people don't work for you. What do you do? This is the cover of Make magazine, which is kind of the Bible of this emerging DIY movement. And that gentleman there is named Jordi Munoz. When I began my explorations of aerial robotics, I knew nothing about it. And so I went online, and I just started Googling around, and I found that there was this guy who was flying helicopters with a Wii controller. His name was Jordi Munoz. And I got in touch with him, and we started talking. We did a project together, did another project together, and then decided to start a company. And then I thought I should ask a question of, who is Jordi Munoz? It turns out he was a 19-year-old high school graduate living in Tijuana. Never been to college. And we decided to create the company together. And today, this is Jordi and the factory that we run in San Diego. Our factory in Tijuana is going to be opening next month. Our factory in Bangkok is already open. Jordi Munoz is the answer to Bill Joy's challenge. He is, for what we do, the smartest person in the world. I never would have found him in the old model. He didn't go to MIT. He didn't live in Silicon Valley. English is not his first language. He didn't go to any college at all. What he had was passion and access to the greatest information resource the world has ever seen, which is the internet. He found me, I found him, and we were able to collectively put together a community of now 13,000 people who are working on inventing what's basically the future of the aerospace industry. And the fact that he's now 23, a 23-year-old Tijuana native who's never been to college, can be creating the soul of the new aerospace industry in Tijuana, in San Diego, and now in Bangkok as well, is an exact reflection of what it means to take the web's model of creativity, innovation, collaboration, and apply it to the real world. This is an industrial revolution. This is how we democratize innovation and bring the best out of any country. The smartest people now have the ability to get to market and have their ideas recognized and built upon. And so the short form is simply this, that atoms are the new bits. The new industrial revolution starts when we take all the good ideas and the passion and enthusiasm and the energy around the web and we apply it to the world around us. Thank you very much.